Hi guys, so today we're going to do this Codeforces round 724 division 2. It's not rated for me and it's about to start in a minute. And yeah, so apart from that, I wanted to talk about something else. So this is a little funny. So first of all, I'm a grandmaster on Codeforces. So that basically means that I think out of 15,000 something active Indian participants, I'm in like top 10, top 12, something like that. So yeah, so somebody on my Discord server, by the way, link to the Discord server in the comment if you want to join. Somebody on my Discord server said that like upon looking at you here or here whatever, yeah, like here. So he said, upon looking at you, you don't look that smart. Something like he didn't call me that I look. He didn't say that I look dumb or anything, but he just said that you look normal, you don't look smart. And my first thought was like, I think everybody looks normal. But then he gave a few examples, like when you look at Eric or Ashish Gupta, like you can just look at the person and say that, yeah, this is like a grandmaster. And that does not apply to me. So I thought that this can lead to an interesting discussion. So like if you have anything to say about it, you can let me know in the comments. Like anything, like if you think I look dumb, if you think I look smart, or anything other than that, like any explanation about why this works like that, or any other competitive programmer that you think has a good rating but looks dumb. So yeah, you can let me know. Okay, so Omkar has received a message. So we're at the problem, first problem, Omkar and a bad story. Okay, okay, right. So he gives you an array. I think Anton Tiger exactly gave this statement to these people, like whoever made this contest. Yeah, so it's a fun way of putting like that. So you have an array of n distinct integers, and another array is called nice if for any two distinct elements. Hmm, okay, so this difference has to appear in B at least once. Okay. In addition, all elements in B must be distinct. Okay, so like you have the elements and all the differences between them are also present in the array. Okay. And can you add several, maybe zero integers in A to create array B of size at most 300. If A is already nice, you don't have to add any elements. So is it just a yes, no? Oh no, we have to actually print the new array as well. Okay, so I think it is something like, okay, yeah, this is not very trivial, I guess. Like we have to fill in the gaps. So if we have 0, 3, and 9, then what we want to do is we want to put in all the differences between them, like uh, 3 and 9. 3 minus 9 is 6, so obviously 6 should be here. And then, right, yeah, so we need to have, I think if we put in everything, like if we just print every time 1, 2, 300, everything, so won't that work? No. I think from minus 100 till plus 100, if you put in everything, won't that work? Okay, no, it won't, because, yeah, so this will be 200. Okay, so, uh, hmm. I think if we have both negative and positive numbers, it will never work. So, like if we have minus 1 and 1, so like their difference is 2, so we will have to put in 2, then 2 and minus 1 will give us 3, and so on. So like we will have to have all the numbers. So if we have at least one negative number, this will never work. What if we have two negative numbers, like minus 1 and minus 2? Then I think what will happen is that, wait a second, and is at least 2, okay. So if we have at least two negative numbers, then their difference will still be positive, and then we will have a positive and a negative number. Okay, so if we have any negative number in the array, it will never work. and there are at least two numbers. So obviously, if we have any negative number, this will never work. Okay, so all numbers have to be 0 or greater. So all the numbers have to be greater or equal to 0. And after that, I think if we just print everything from 0 till 100, I think it works because all the differences between that are present here. And I hope that's it. Okay. Right. So let's implement this. Okay. Uh, hmm. Okay. So we have, I think, n. Then we take n. Right. After that, what we want to do is we want to have, okay, right. So we want to have the array. Take that as input. Why did I take the input like this? Oh, the lead code effect. Knew I shouldn't have done that. Okay. So Boolean variable for negative. If AI is smaller than 0, then we have neg equals true. And if we have at least one negative element, then we will just see out no. Okay. And if we don't have any negative elements, we will see out. We can just print the same thing, I guess. Just all the numbers from 0 to 100. So, right. Just let's just see out yes, and then leave a line. Then we can print 101. Leave another line, and then just print all the numbers from 0 till like 0 till 100. Okay. Yeah, so I think this should work. For one of the test cases, for the second last one, it should be no, and in all of the others, it should be yes. And yeah, so this has to be the output. I think this is correct. Okay. Why does this happen every time? Mm. Hmm. I cannot even read the name of this problem. I cannot pronounce this. What is this? Is it like a Prinzessin der Verurteilung? Yeah, definitely. I look dumb right now. Okay, so okay. Yeah. So usually when you have an italic line like this, it just means that you don't have to read it unless you want to. But okay, so I think we don't want to read this one as well. But yeah, this one we can read. So we have a string of n lowercase Latin letters. You think that the max of this string may help you find the meaning behind the message. The max is the shortest string that does not appear as a contiguous substring. Okay. If multiple strings exist, the lexicographically smallest one is considered the max. Note that empty string does not count as a valid max. Okay. Okay. So we just have to find the max of the string. So if like unless it has all the 26 characters, the answer will be just a single character. In fact, the smallest character that is not present in it. Okay. And what else? Wait a second. So we have 26 one character strings. Then we have 26 times 26 two character strings. Okay, then we have 26 times 26 times 26 three character strings. Okay, those are a lot. Can we? Hmm, hmm. They don't have to be disjoint, right? We can kind of reuse two of those for the third. Even if we do that, 26 times 26 times. What is 26 cube? Okay, yeah, so that's definitely more than so that's definitely more than 1000. That means the answer will never be more than three characters. Okay, right, so the answer will never be more than three characters. So is that all we have to do? Like find all the one character or two character or three character things and try to find them in this whatever this is. It works, otherwise it doesn't work. You will have just three and substrings. We can put everything there. Hmm. Okay. First sort it according to length, then sort it according to the lexicographical order. Put all the three and strings in there. Then we can just try to find which is missing. Yeah, this is like hmm. Okay. So I know a lot of ways to actually implement this. Not sure which one to use, but like, yeah, we have to start at some point. So the approach that I'm going to be using is that first I will fix the length of the max and try to find that length. Okay, scrolling not working. Okay, so we have n and we have the string. Okay. So then what we want to do is we want to fix the length. So something like length can go from 0, 1, that's to start from 1 till 4. Yeah, so I don't think the length will never have to be more than 3. That's enough. But I think we can run an infinite loop here. Doesn't matter because I'm pretty sure we'll quickly find the answer. Okay, so we will try to find a string of length. Okay, how do we find a string of length? There can be a lot of such strings, right? Okay, so I think it is something like 26 to power length. That many strings we will have. Okay, so the number of strings that we will have will be 26 to power the length. Okay, then what we can do is we can actually run a bit mask kind of thing, but with 26 things. Like when we will actually iterate on this number, we can break it down into a number of 26, like in the 26 number system. Like we can have 0, 1, 2, 3, till 26, till 25, and after that we will have 10. So that means like 0 means A, 1 means B, and so on. Like this we can do. So 10 would mean B A, I guess, and then 11 would be BB, and so on. So that something like that we can do. Run the masks from 0 till num. Okay, so what do we do with the mask? We have to actually make the string now. Okay, so let's say string T, run a loop from 0 till length. Okay, what do we do now? Wait a second. So we need a temp mask. Okay. T dot pushback A plus the digit that we have here. So the digit will be temp mod 26. Then we will do temp divide equals 26. And this is A plus the digit. Okay, so we will make all the strings like that. Okay, let's just print all the strings for now. Let's see how is it working. Only till length 4, I guess. Okay. 1 A. Okay, we have all the characters from A. Then we have, oh, okay, this order is bad. This shouldn't be the order, right? After A we should have AB instead of BA. So I think we can just reverse the string. Let's see the order here. Yeah, just reversing would work. Okay, so we should just reverse the string that we have made. Okay, now it should be fine. So we have A to Z, then AB, AC, AD, and so on. Okay. So we want to find the first string that is not present here. Okay, so how do we do that? Right, so let's try to find this string in our string, in our input string. And I think we can do it in linear time also. Like that shouldn't be a problem. If you do it in linear time, what would be the time complexity? Shouldn't be more than like 1 million, right? Hmm. Yeah, I think we can just do it in linear time. That shouldn't be a problem. We can find each string in linear time, and that will work. Yeah, that sounds really. Obviously, I can use a set and put everything there. But I'm thinking, will it actually work if I do it in linear time? Even if there are 17,000 strings, then also we only have 7 into the power 7. Yeah, 1 into the power 7. Yeah, it will work. So we just have to find the string in that. So let's see how to find a string in C++. Find a string in string C++. Like obviously I can do it, but I want to see some inbuilt function, I guess. Okay, we want to find the pattern str2 in str1. So what do we do? Is that it? What? What does it return? What does it return if no matches are found? Okay, I think string n post. What is this? -1. Okay, so it returns -1 if it's not found. Okay, so if s dot find p equals -1, then I think this is the answer. We just print P and return. Okay, this is like a very brute force-ish solution, which I hope should work. Okay, working on the samples. Yeah. Okay, so this is like a very lame kind of thing that I've done here. I could have obviously optimized it like many times, but yeah, it worked. I didn't want to optimize it much because obviously so the people who are actually watching this video for the B problem, they are not very talented. So just wanted to have a very simple brute force type of solution. So this is here what I'm actually doing is I'm first iterating on the length. This is like iterate on the length, then make all strings of that length. Obviously there could be some other way to make all strings of that length. What I did is like write numbers in this way, like you have A, B, C, D, Z, and after Z you write AA. No, wait a second. It's more like you have AA, AB, AC, AD, and so on till AZ. And after AZ, what you will do is you will write BA. Right, something like that. So yeah, then BB, BC, BD, and so on. So if you look at it carefully, this is actually how the Excel columns are numbered. There are other ways to get this numbering, but what I did is after we fix the length, what you can do is you can think of this A as 0 and this A as 0, this as 1, 2 till 25. So what's happening is we have a like if we compare this with our number system, normal number system, then it goes something like 0, 0, 0, 1, 0, 2 till 0, 9, and after 0, 9 we get 1, 0, and then 1, 1, 1, 2, like these are 11, 12, 13, 14, something like that. So instead of having 10 digits in total, I'm having 26 digits, and using that I'm making my string. So this is the same thing. So like we have 0, all zeros from 0, 0, 0, 1, 0, 2, 0, 3 till 0, 25. And after 0, 25, I directly go to 1, 0, and then like this is 10. So this is called a number system with radix 26. So using such a number system, I can enumerate all the strings of a given length very easily. So like if I actually count from 0 till 26 square minus 1 and make these numbers like this. So then we will and then convert these numbers into characters, like 0 becomes A, 1 becomes B, 2 becomes C, and so on. So if I do like this, then I will actually find the characters in that order, and I just have to find the smallest one that is not present in the string, and this will work. Why does this work? So finding the smallest thing, I think this works in linear time. So this function can work in linear time. So we have O of n time to actually find it, and then right, so then we are actually making all the strings, but the thing is it will never take too many strings to actually find that thing. I don't think there can be more than O of n strings that are present as substrings in that will work. Maybe O of n squared. Can this fail? The way I think of it, to have a new string, you need to have at least one character. For example, if you want strings of length 3, so each string will have at least one character that is unique to itself. Like you can assign the first character of each substring of length 3 to that string, then each is having at least one character. So like to have, if you have only 1,000 characters, I don't think you can have more than 1,000 contiguous substrings of length 3. So yeah, that's why. So I think that's why it works. Obviously, if you're worried about that, what you can do is you can put all the strings in a set first, and then you can just find it in the set. That will be faster. But yeah. Okay, so what is this one? Italic statement. I don't want to read it. So this time the brothers are dealing with. Again, they have a string with n characters, I guess. This one is a little longer. So either the character is D or K, and you want to make some number of cuts on the string, partitioning it into several contiguous pieces, with each with length at least 1, as evenly as possible. Ratio of D's to K is same in each chunk. Okay. Kaeya, a curious thinker, is interested in the solution for multiple scenarios. He wants to know the answer for every prefix of the given string. Okay. So what? Right. What? Yeah. Okay. Okay. Something like we want the ratio, right? So I'm thinking if here also the ratio is A to B, and then here also the ratio is A to B. So if we actually combine both of these, won't the ratio still be A to B? Something like if we have 1 is to, or let's say X is to BX here, or RX here, if R is the ratio. So if we have X is to RX here and Y is to RY here. So if we add X plus Y is to RX plus Y, then we can cancel out this part. So then the ratio is still 1 is to R, and here also it was 1 is to R. Yeah, so if we can merge the parts, and then the ratio won't be different. So what this means is that the ratio in each part has to be the same as the entire ratio, right? So I think the greedy also, the partitioning also has to be greedy. What I mean is, let's say if the total ratio is like 1 is to 5, and then when we start moving from left to right, whenever we find the ratio of 1 is to 5 here, so we know that this ratio is 1 is to 5, and we know that the entire ratio is 1 is to 5, that necessarily means that this ratio also has to be 1 is to 5. But does that mean we should partition it here? Maybe it would be better to not partition it here and partition it somewhere else. Okay, let's think of a scenario in which we partition it somewhere else. So if we partition it somewhere else, like for example here, and if we know that this ratio is 1 is to 5, and this remaining ratio is 1 is to 5, so we know that this is 1 is to 5, this is 1 is to 5, obviously this will also be 1 is to 5. So instead of making one partition, we can make two partitions. So obviously whenever we find the earliest point of partition, we will perform a partition there. But this only works if we have the entire string. So if we have the entire string, we can just find the partition, we can just find the ratio, and then just greedily iterate from left to right. And whenever we find that ratio, we will just perform a partition there, like just cut it here, right? So okay, I think I get it. It should be something like we will store all the we will store the frequency of all the ratios that we have found. Okay, so something like store frequency of all ratios. Okay, store the frequency of all ratios, and then at any point whenever we find the ratio, let's say 3 is to, like if you find 3 is to 17, what we will do is in this entire array till this point, if we have found 3 is to 17 two times before, like let's say this was also 3 is to 17 and this was also 3 is to 17, and by this line I mean that this prefix has 3 is to 17. Okay, so what I mean to say is if this prefix has 3 is to 17, this prefix has 3 is to 17, this also has 3 is to 17, then I think we can just make 3 parts like this and we're done. Because if this has 3 is to 17 and this has 3 is to 17, obviously this also has 3 is to 17. We can make a partition here, then we can similarly make a partition here. Because if this has 3 is to 17, this has 3 is to 17, and this also has 3 is to 17. So yeah, we just have to count the number of times we found the same ratio. Okay. How do we store it? So we have to store it as fractions because we can get something like 3 is to 0. So we cannot just divide it. This will lead to some undefined value. Right. So what we want to do is we want to store it as fractions. And we can actually make a structure of fractions, but again, I don't want to confuse people. So I will do it in a simpler way. Okay. What do you have to print? Okay, for every okay. So map parent int frequency. This is storing the frequency of all the ratios. The ratio I'm representing as the parent int. Okay. Then right intent in n. Okay. Okay. And we have the string. So we need to have counts for d and k both. Okay. Go on the string like this. Okay. Whenever we find d, we do d plus plus. Whenever we find a k, we do a k plus plus. Okay. Now we have the ratio d is to k. Okay, so we have the ratio d is to k now, and what we want to do is we want to put this ratio in our container and then increase that thing. So we will do something like let's put it as x is to y. So we will do something like frequency of x comma y plus plus. But there's one problem is that this would consider 1 is to 2 and 2 is to 4 differently. So we want 1 is to 2 and 2 is to 4 to be same. So what we will do is like we will find the GCD between these two, whatever the GCD is, x and y. Then we will divide both of them by the GCD. Okay, x divide equal to g, y divide equals g. Now they're in the lowest terms, and now there's just one more problem, and it's that if one of them is 0. So if what will happen is, yeah, I think that's fine, because if even if one of them is 0, then the GCD will just be the other one and it will just become 0 is to 1 or 1 is to 0. I think that's fine. Okay. So in this way we have reduced to the lowest term. So if you're wondering what will happen if we have something like 5 is to 0, so the GCD of 5 and 0 will be just 5, and then we will divide both of them by 5 and it will become 1 is to 0. Similarly 0 is to 1, and everything will be in lowest terms. So yeah, so that's how we can increase the frequency like that. And what do we print here? I think we just print the frequency of x comma y. Okay, leave a space, leave a line. We've taken test cases, right? I think they should work. The answer should be, I don't know what it should be. 1 2 1 1 2 3 4 5 6 1 1 2 1 1 1 1 1. Yeah, it looks okay to me. Let's submit this. Why? Why? Why do I always have to submit the same file twice? Okay, yay. Now we have Omkar and Medians. Okay. Um, okay, so what is this problem? Omkar and Medians. Does it have something to do with the medians? Probably. Oh, the answer is just yes, no. Wow. It's a little strange for a D problem. But let's see. So he keeps losing his array, but Omkar might be able to help. So they have 2k minus 1 elements. Is k even given in the input? Not. Then you have, so first you have an array of 2k minus 1 element, then you have another array of k elements. Oh, okay. So these are the medians of these elements. Okay. Mm-hmm. Mm. Oh, oh. Interesting. Interesting. Hmm. Okay. We always have odd number of elements like 1, 1, then we have 3, then we have 5 and 7 and so on. So the median will always be the middle element in sorted order. If we sort them and take the middle element, that will always be the median. And okay, so okay, right. So we have the array B already, and we want to check if it represents an array of medians or not. Okay. So okay. So like after every step we have inserted 2 elements. So like I think initially we only had 6 here. I mean like here obviously we initially only had 6, and after that if we like from the 6 when we reach this 2 or whatever element here is, wait a second, is it shuffled? No, it's not shuffled, it is in an order. Yeah. So we have 3 options I think. the two elements that we insert here are either both smaller or both bigger, or one smaller, one bigger. Okay. So if we put one smaller and one bigger, then what will happen is this will still remain the median, and again we should have 6 here. But if we put one smaller and one bigger, then sorry, if we put both smaller, then this will decrease, and if we put both bigger, then this will increase. So since we have a 2 here, then it is like obvious that the element that we inserted are 2 and something smaller than 2. So smaller or equal to 2, I think. Yeah. So we inserted 2 and something smaller equal to 2. Then when we reach this point, our median becomes 2, and this is our current array. Okay. Then our median becomes 1. So what can that mean? Okay, now this can mean a lot of things. Right, so there are a lot of ways for the median to become 1. Okay, let's say something happened, like 1 came here, and maybe something even smaller than x came here. Although there's another way that x itself was 1 and then the other two elements were both smaller than this x. But I think it's the same thing, like we have a 1 and we have two unknown elements. Yeah, so that would be the same thing. We have a 1 and we have two unknown elements. So yeah, so now the median becomes 1. And after that, the median becomes 3. So I don't think that's possible. How can the median become 3 after that? Like putting in 2 more elements can only shift this pointer by one spot, right? So I think this is a no. I think this has to be a no here. Okay, so yeah, this backup light is really bad. Okay, yeah, so I think the median can only shift by one, right? So like even if we put a 3 here and like something very big here, the median cannot go above this, right? So for the first one, the answer should be no, I think. Is it? Yeah. Okay, so that's the whole idea. Right, so the median can only shift by one in one space, one spot. It cannot jump an element like this. Like if we had 1, we will have to go back to a 2. We cannot directly go to a 3. We cannot skip an element. But if the tables were turned, if we had like 3 and 1, we could have gone back to a 2, I think. Because obviously we can insert a new element in between. Right, so we will start with the median. We can either increase or decrease. But we have to be aware that we are always doing it by one spot. And we can never jump elements. I think that's the only constraint that has to be satisfied. We can never jump elements. Let's try this. Let's try this one. Okay. So we have 4, -8, 5, 6, and -7. Okay. 4, -8, 5, 6, and -7. Okay. So I'm glad I didn't read the sample explanation because they were a bit off. 4, -8, 5, 6, and -7. Okay, so we start with 4, we take a little smaller element, that is -8. Then aren't we jumping? So this is also no, because we jumped. How can we have something bigger than 4? So what is this test case? First, second, and third. Third should be no. Okay. Let's try this last one. I want to see a yes also. So this is like 2, 1, 2, 3. I think we start with the 2, go down on 1, come up, go more upwards. It should be a yes, I think. Wow. Okay. Here also I think maybe we jumped. From -8 to 2 we didn't jump, but from 2 to -6 also we didn't jump. Oh, wait a second to make it -8 to -6 -5 -4, no jumps till now, but then we have 3. Okay, that's a jump. Let's just do this one and then we're done. Okay, so we have 1, and after that we still have 1, so I don't know, let's just ignore it. Then we go up to a 3, come down to a 1. Okay, go down to a 0, then -2, then a -1. Right, so again no jumps. Right, so I think no jumps mean that it's fine. So as long as we're not jumping over any element, that's fine. So that's what I think of this. Right. Too much light. Okay, yeah, it's fine. Right, so we have to make sure that we're not jumping over any element. Okay. Test cases. Can we do this online? Yeah, I think we can do this online. We just need a set of elements to make sure we're not jumping. Like the set should contain the elements, right? Okay. And then we can just take inputs like this. At the end, we can just print yes. Go to the next test case. And wherever this fails, we will just print no in return. Okay. So int x, screen x. Okay. So if s dot empty, like if there's nothing in there, just s dot insert x and continue. Because if there's just one element, then that's fine. What do we do when we get a second element? So what we want to check is that between x and the nearest element, so we also need to keep track of the last. So we need to keep track of the last. Okay. And you can say last equals x. Right? Here also last equals x. Okay, so we know the previous element. Instead of last, I think it's better to call it previous. Okay, so we know the previous element, and we know that whether we have increased or decreased, and there should be nothing between the previous and the current. Okay, we want to find if there is any element that is between previous and current, and if there is, then that's a problem, right? It shouldn't be there. Would be bad if there's an element between them. Okay. Okay, so we have x, which is the current, and we have prev, which is the previous, and we want to see if there's any element between them or not. Okay, so let's say the small equals the minimum of these two, minimum of x comma previous, and the big is the maximum of these two, x comma previous. Okay, right. And okay, wait a second. So I think now we can just insert x in the set. Okay, so now we have both x and previous in the set, and what we want to do is we want to check the upper bound of the smaller one, and it should be the bigger one. Okay, so if star s dot upper bound small is not equal to big, so that means there is an element between those two, then it's wrong. Then we just see out no and return. Otherwise, we'll continue the thing, and if we reach the end, then that means everything's correct, and we'll print yes. No, yes, no. Okay, we got an extra no here. Oh, okay. We need a multi-set, I guess. No, wait a second. What do we do if x equals prev? We can have special provisions, I think. If x equals prev, we can continue, I think. That's fine, nothing's happening. We're just inserting a very small element and a very big element. Doesn't matter. Why is it still no? Why is this one no? This is, I think, very, very wrong. What's happening? Definitely something wrong I'm doing. What did we jump in the second one? Let's just print everything that's present in the set. Minus 7, 2, 3, and 4. What? Why do we have elements from the previous? Oh, okay. Yeah, okay. I get it. Okay. That's my fault. Right, so when we return from here, we don't really take all input. We have to make sure we take all the input. We do something like actually not. I'm thinking we should just take the input first. What is this? B. Okay, after taking the input, we can just loop on this. Okay, this is much better. Now I think it should all be fine. No, yes, no, double yes. And then, yeah, it's fine. Two new messages. I'll see them later. I don't want to see them on stream. Could be something personal. Okay. Hey. So should I read this problem or not? In a little hurry right now. This is easy. I'll do it. Otherwise, that's it. This is the end of this video. Okay. I can do it in like 20 minutes. Then only I'll do it. It doesn't look like I can do it in 20 minutes. What is this? Hmm. Hmm. If the number in some cell is strictly larger than 0, it should be strictly greater than. It should be greater than at least one of the cells adjacent to it. Okay. So, what? Okay, so you can't have like 1 1 1 1 or 2 2 2 2 something. What do we have to do? How many different assignments exist? Oh, right, we cannot have very big numbers. Mm-hmm. 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 Hmm. 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 So zeros are 0. I think this can only be 1. Why the answer is 2. They're like -1. Oh, okay, okay, we can put a 0 also. Right. And so I think 0 we can put anywhere, and adjacent to the 0 we can put a 1, and adjacent to any 0 we can only put a 1, and should be at most 1, right? So to put a 2 we need to have all 1s surrounding it. Then to put a 3 we need to have all 2s surrounding it. Otherwise we can't really do it. Or is it, if we have 2, we can only have 1 2 and 3 around it. This is like a contour, I think. Like the height is kind of increasing or decreasing or something like that. Yeah. Hmm. So yeah, so I don't immediately know this. I have to think about it. And I'm a little short on time today. Wait a second, is something written here? Omkar, right? Omkar, obviously. This is smart. Hats off to whoever made this problem. This is really smart. Like, not everyone will notice this so quickly, but like if you zoom it and watch it closely, then this is like Omkar. Yeah. Okay, so I think that's it. And yeah, so thank you for watching. I have to get to some other things. Yeah, thank you for watching.